So the idea is like if we want so the idea is like we should to do the secret sharing scheme we need so suppose we want to have secret S, right? And then want to give points to n people. There are some constraints that you need to make sure that you meet that constraint. First of all, if our secret is S, okay, and the modulus M, we do everything modulo M, right? So if M is less than S, then your secret will be gone, right? After mod M. So you need the modulus to be larger than the secret. And moreover, you need to give people points, right? So the x coordinate has to be larger than n because you need n points, n value of x, right? And you don't want to give 0 as well because the 0 is the secret. So the modulus m has to be larger than s and m as n, okay? And then we would pick a random polynomial of degree k minus 1 because we want k people to be able to recover the polynomial. Okay, and we want these polynomials to be such that P0 is S. So the polynomial should be of this form. Some Px is going to be of degree minus 1, right? So it's going to be xk minus 1 plus xk minus 2 plus xk minus 3 and some random number ak minus 1, ak, and so on. So this should be some random numbers. And finally, some a1 x1 plus s. So s is the last the term with degree 0. Okay. So that's why when you plug in 0, you get s. Okay. And then you give pi to each person. Person 1 gets p1. Person 2 gets p2. Okay. So they know x as well. That will be easy. But you can also give x. That will be fine as well. And then for any set of k people, so for any set of k people, they can recover p, okay, because using Lagrange interpolation. So this is one part of the correctness of the process because if you have enough people, you can recover the message. Okay. Now we need some other thing. We need to make sure that for any set of k minus 1 people, okay, they should know nothing about our secret. Okay. So if they because they know quite a lot, right? So if k say k is 10, if you have 9 people, you should know like 90% of the secret, right? But this scheme allows us to say that they know nothing. Okay? We can prove that they know nothing. Okay? So to see that, let's look at this. So I'll give you the idea. I'm not gonna fully prove it. Okay? So suppose there are k minus 1 people. And you know k minus 1 point, okay, and that's one. So now, since you only have k minus 1 point, if you look at any possible secret that we have, if we add this point to the set, there will be one polynomial that goes through all these points and pass through this secret. Okay, if you have another secret to be like 2. There is another polynomial that go to this point and then pass through 2. There's another polynomial that.
Oh my god.
So for any possible secret, there's one degree k polynomial that pass through it. Okay. So knowing only k minus 1 point doesn't rule out any possibility of any secret. So that's why it seems like you know nothing, right? Because any secret is possible. Okay, so because like think about the case when you have degree 2. If you have only 2 points, for any possible secret that you have, there's one parabola that goes through it. Okay, so that's one parabola that goes through that. There's another parabola that goes through this 2 point. Like so for any possible secret, there's one parabola that goes through it. So you have all the possible secret are not eliminated. So knowing less than k points doesn't give you any information at all. So that's the idea. That's why this secret sharing scheme is safe. Okay. So we can actually prove that. Okay. So let's go back. So the reason we can prove that is because this two property of polynomial. Okay, these two properties. The first polynomial, the first property says that a non-zero polynomial degree has at most d roots. Okay, this property we'll use it to prove property 2. Property 2 say if you have d minus 1 pairs, okay, from there is exactly one polynomial degree d that's passed through all these points. So in our case, suppose we have polynomial degree 2, right? You can pick any points here. There will be one polynomial that goes through this secret. So any secret is possible. Okay. So we will prove quickly. We will quickly prove property 2 using property 1. And property 1, if you want to see a proof, I have a video clip that you can take a look. But let's get property 2 done. Okay. Okay. So to prove property 2, there are 2 parts. Okay. The key thing here is unique. The word unique means like there's exactly one polynomial that satisfies this. So that's why when you start with a polynomial and when recall what you did in the secret sharing scheme, right? You start with a polynomial and you give point to your friend, and you want your friend to recover that exact polynomial, right? What your friend did is basically find a polynomial that goes through these 3 points. If there are more than one polynomial that goes through these 3 points, then your friend might not get exactly the polynomial that you have, right? But because there is exactly one polynomial, that's unique polynomial, that's the reason why your friend will always recover your polynomial, because that's unique. So the word unique is probably really important to this. Okay. So to prove uniqueness, unique means like one, exactly one. So to prove uniqueness, you need to prove 2 things. Okay. First, you need to show that there is at least one. Okay. There is at least one polynomial that goes through these points. And also, you need to show that if there is no more than one, they have to be equal. That's why they are unique. Okay? So 2 parts, we need to prove 2 parts. So that's the proof. That's a proof of some parts. Okay, so this lemma says, okay, so let me go back a little bit. Okay, property 2, so let me write it down here. So to prove property 2, you need to prove 2 things. One, is proof there exists at least one polynomial. And then if there are more than one, they have to be equal. Okay? The first part, we didn't prove it, but we show you how to construct it. So this is from the Lagrange interpolation. Okay, the Lagrange interpolation that we used previously always succeed, right? Because you just plug in the x and stuff like that. If you do the calculation correctly, you get a polynomial that goes through this d plus 1 points. So we know that there is at least one polynomial satisfying this condition. So there's at least one polynomial that goes through this point. Then we need to show that if there are more than one polynomials, they have to be equal. So that's the second part. That is unique. So if this statement doesn't have a uniqueness, then we are done. We don't have to do anything. We just learn the Lagrange interpolation and we're done. But if they're not unique, our secret sharing scheme will not work, right? Because you might come up with some other polynomials that go to this point, but then it's gonna be a different one. Okay. Okay. So to prove the uniqueness, okay. So this is the lemma. Okay, it says that I'm gonna go it really quickly, but the idea is simple. Okay, so if you have two polynomials of degree at most d that share d plus 1 points, okay, then they have to be equal. Okay, then they have to be equal. So to prove that, so let me give you a picture first. So suppose you have two, so polynomial degree d. So suppose you have the first polynomial f, and you have the other polynomial g, and they share d plus 1 points. This is g, and they share d plus 1 points. Share. Okay. Both are polynomial degree d. Okay. Now let's look at another polynomial. Okay. Let's have polynomial h. Let hx be this polynomial. Fx log gx. So what's the degree of h? F is polynomial degree d. G is polynomial degree d. If you subtract polynomial degree d out of polynomial degree d, you also get polynomial degree d. Right? Because the largest exponent of x is d. You didn't do multiplication, you just subtract, right? So h is also s is a polynomial degree d as well. But what is x? So if you do a subtraction, h will look like this. At this point, when on any point where g and f are intersect, right? H will be 0, right? H will be 0, right? So this will be 0, and H would look like something up and down. So this is like that. Okay. And what are these? These are roots of h. Right? These are roots of h. Okay. Now, how many roots does h has? So h has d plus 1 roots. Okay. A polynomial degree d with d plus 1 roots is 0. Because non-zero polynomial of degree d, non-zero polynomial degree d has at most d roots, but h somehow has d plus 1 roots, so it has to be 0. So let's try to be concrete. So suppose you have a polynomial degree 2, right? It can have 2 roots, right? Like that. But if it has 3 roots, then you have a problem now, right? So it has to be 0. So same thing. So when you have so h has d plus 1 roots. So polynomial degree d with d plus 1 root is gonna be 0. Now when s is 0, what does it mean? It means that fx minus gx is 0, so fx has to be equal to gx. So that's the proof. It's exactly this proof. Same thing, but I just draw you a picture. So Suppose we have f and g, right? And we let hx to be g fx minus gx, so it's this term, and it's also a polynomial of degree d. H has d plus 1 roots because fx and gx share these points, so they have 0. So every xi is a root of hx, but if hx is non-zero, it has at most d roots, but now it has d by plus 1 root, so it has to be 0. So when h is 0, fx equals 0. Fx minus gx is 0, so fx equals gx. So that's the proof. Okay, so that's why they are unique. Okay, because polynomial degree d, different polynomial degree d they cannot share more than d points. If they share d plus 1 point, they have to be exactly the same. This is really crazy property of polynomials. Okay, which rely on property 1. Okay, to prove property 1, it's not that hard, but we don't have time. But you should, at this point, you should somehow know property 2. And with this property 2, we can show that our secret sharing scheme is safe in the sense that as I showed you before, if you don't have enough points, any secret is possible. So knowing k minus 1 point instead of k doesn't reveal you any information about the secret, because you can find a polynomial of degree k that pass through every possible sequence and also pass through this k minus 1 points. Okay, so that's it. All right. So that's it for our course. Thank you so much.